Hi, before we move on to the statistical decision tree, let us quickly have a short overview of the types of data. We have nominal, ordinal, interval, and ratio data. The first two are sometimes also known as qualitative or categorical data, and interval and ratio is also called as quantitative or continuous data. Now, the type of statistical test that you use depends upon what you want to see. Are you trying to see a relationship, or are you trying to see a mean difference between the groups? You can only see a relationship if your independent data is a continuous data. So let's say you have a variable age, which is continuous. Then you can see a relationship between that variable and your dependent variable. Now, if your dependent variable is a categorical variable, you go on to use logistic regression. So for example, independent variable age and dependent variable is whether there is a risk of cancer, yes or no. But if your dependent variable is a continuous variable, let's say, what is the risk of cancer ranging from a certain degree to a certain degree on a continuous level, then you're supposed to use linear regression. So in this way, you can predict the relationship between your independent and dependent variable. But let's say your independent variable is categorical. So for example, gender, male and female. Then you cannot see a relationship, but what is called as the difference between groups. Now again, depending upon your dependent variable, whether it is categorical or continuous, you can check the difference between the groups using a chi-square test or a t-test or ANOVA test. So we use a chi-square when both dependent and independent variables are categorical, and we use a t-test if the dependent variable has two categories or two groups, and an ANOVA test if it is two or more than two groups. Now the same principles apply to ranked data or ordinal data like we had previously discussed. Ordinal data, or when your parametric assumptions fail. So parametric tests are basically those in which you have information about the population, and therefore you can make an estimation, and then you go on to apply your t-tests or ANOVA tests. But let's say you do not have any information about the population and hence you cannot make any assumption. Then you move on to perform one of your non-parametric tests, such as those that we are going to discuss. So for non-parametric tests, the variables and the attributes both can be tested upon by using one of the non-parametric tests. And these tests also exist for your nominal and ordinal data. The only difference is that these tests are not powerful enough since you have not made any assumptions. So again, like we previously discussed, you can either check a relationship or a difference between the groups. If you want to check a relationship, you go on to use the Spearman's row test. Spearman's row is like your Pearson's R test, which is used if you want to check a relationship between two variables, but when your data is parametric. When you want to see a difference between the groups, again, depending upon your independent and dependent variable, you move on to choose the test. So if your independent variable has two categories, you go with a Mann-Whitney U test, which is also called as the Wilcoxon's ranked sum test. And if you have more than two groups, then you go on to use the Kruskal-Wallis ANOVA, which is like your ANOVA that you use when you have more than two groups. Now, if your dependent variable is more than one, that is, you have two dependent variables, then you go on to use your Wilcoxon's matched test, which is also called as the Wilcoxon's signed rank test. And this is because your data is no more independent and you have something called as repeated measures, or matching as it's known as. If you have more than two dependent variables, you go on to use your Friedman's two-way ANOVA. Now the thing about ANOVA is that it tells you whether there is a significant difference between the groups, but it does not tell you which groups are significantly different, and that is why you conduct